All right, welcome to the first video lecture for Activity C, in which we are starting circles. So that C in Activity C stands for circles. This is the video for lesson C-1, which is the first video, and it's on circle basics. So we'll talk about what a circle is and introduce some stuff about it. What is a circle? A circle is the set of all equidistant points from a given point. So basically, and that given point is called the center. Okay, so if we look at our example below, we have a center right here, some point directly in the middle, and every point on our circle will be the same distance from the center, meaning that if that was 3, then that's 3, and if I drew another one, that's 3. Okay, and that's how we get every point around here. Basically, you think about it, you have a if you have a big stick and you stand around in one spot and you spin around, you are creating a circle because that stick is the same distance around. So you have a circle around you, essentially. All right, so let's talk about parts of a circle, these lines and segments of a circle. Our first one we'll talk about is a chord. A chord is a segment just with endpoints on the circle. So remember, segments look like this, 2 endpoints. So a chord has those endpoints will be on the circle. Very general term right here. So here's our example. Chord, there's 2 endpoints right there. Now a tangent is a line or part of a line that intersects a circle at exactly one point. That's our important thing right here. Only once, okay? And it will lie outside the circle. So our tangent right here, we see it's a line, or in this case it's a line, intersecting our circle only once. Okay? I think of it as a ball on the ground. That's what it looks like, right? So this point in which the tangent intersects the circle, we call the point of tangency. Okay, that's the point of tangency. All right, moving on to radius. A radius is a segment with one endpoint on the circle, meaning on the outside of the circle right there, and then the other endpoint will be at the center. This is just that distance from which every point to the center is equal to, right? The radius of any radius you draw in a circle will be the same length, okay? All right, notice that that's a radius, and also that's a radius, and that would be a radius over here if I can scoot this down. So there's like 3 radiuses total drawn in here. All right, and to get to our last one, leading into that from radius, we talk about a diameter. It's a chord, so we know that 2 endpoints will be on the circle. It's written pretty terribly, but forgive me for that. So a chord that passes through the center. So it's just a special type of chord. If you look over here, this diameter, of course, is a chord. It got the 2 endpoints right there on the circle. And then if you look at the line, it of course goes through the center. Okay. Notice that this diameter is made up of 2 radiuses, right? So that leads us to our little example right here. Diameter is equal to 2 times the radius. And we use this mostly when we're talking about the length of the radius and diameter. Okay. All right, number 1. In the circle, draw and label each geometric term. Okay, so this one, first, it wants us to label the center O. Done. Now we're going to draw a radius OA. No, let's not draw. Let's draw it right here. Or there. So there's A, and then we draw a line between it. That's all a radius is. Okay, so for chord BA, we just need some other point B. We already have A, and then draw a line between them. Arguably a better line than mine, but there we go. And then diameter CA, so it does matter where we place the endpoint C, because we know it has to have one endpoint A. We already have A here, so there's only one diameter possible with that endpoint right there. So goes through the center and across that like that. That's how you get diameter CA. Your drawing could have looked a little different than mine, and that's okay, right? Just as long as it has the basic concepts here. All right, number 2. How many radii are shown in the figure below? So let's count. Here's 1, there's 1, there's 1, and then there's another one right there. I don't see any more. That's a chord, so that'll be just 4. Okay. How many chords are shown? I see 1 right here, And then the other chord would be the diameter right here, 2, and that's it. Okay, cool. Using the given circle, draw a tangent line and a radius to the point of tangency. Let's try to draw a tangent line. Or it's gonna be hard on this thing. Okay, that's good enough. All right, now we're going to draw a radius to this point of tangency. So my point of tangency probably should have been a bit right here. That looks more like the line I drew. Let me erase that. Okay, and then I will draw a radius, or attempt to draw a radius to this. Okay, and notice that, look, they look pretty perpendicular to me. And then that's what part B wants us to do. Look at the radius, where the radius intersects the tangent line. Describe the relationship between the radius and the tangent line. We're going to say that they are perpendicular. Awesome. So let's fill in the blank below right here. A tangent line is perpendicular to a radius that is drawn to a point of tangency. So yeah, this is going to be perpendicular. Okay, so we'll use this fact now to show if something is tangent for 4, 5, and 6. So given that OT is equal to 5, okay, so let me draw that in. OT, that's equal to 5. Put it up here. Okay, OXT is equal to 12, and then OX, that's equal to 13. Is XY tangent to circle O at T? So basically we're trying to show, we're trying to figure out if the measure of angle OTX is equal to 90. All right. So we want to know if that's a right angle. We want to, so if it is, then they intersect. Then they are perpendicular, meaning that. And then what that means is that OT XY would be tangent to circle O at T, and that's due to the fact that this is right here, right? A tangent line has to be perpendicular to a radius. If it's not, it's not a tangent line. So I essentially right here, I have a possible right triangle right here, right? With these would be my possible legs, these would be my possible hypotenuse. The best way to check if a triangle is a right triangle is to plug the 3 sides into Pythagorean theorem and see if they work, because that only works for right triangles. So remember, Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to plug in this part first, and then I'll plug in the c squared and see if they are equal to each other. So to know which ones are a and b, we know the hypotenuse is c for sure, and we know hypotenuse is the longest side, right? So we'll plug in the 5 and the 12 for the a and b. Those are the 2 shorter ones. So we have 5 squared plus 12 squared. Okay, so that gives me that's 25 plus 144, and that equals 169. Okay, now we're going to check the 13 squared. That equals 169. So since they are both equal to each other, we can say yes, XY is tangent to circle O at T. Awesome. So we'll do a very similar thing in number 5. Okay, let's check it again. So we know that OT, again, this one is going to be 4 this time. And then YT is 8, and then OY is 10. Is XY tangent to circle O at T? So let's take our 2 smaller ones, plug them in. This would be 16 plus 64. Adding those together, that's equal to 80. And let's check the 10 squared. That's 100. So no, they do not equal. So no. So that's not a right triangle, and then no. My answer is no. I'll just put a no here. Okay, it's the same thing. Okay, and our last problem for this video, given that xy is tangent to circle O at point T. All right, stop there. I know that that's a right angle based on just that statement. Cool, finish. What is yt if OT is equal to 18 and OY is equal to 24? So we're just solving the missing leg in this right triangle. So Pythagorean theorem, x squared plus 18 squared equals 24 squared. X squared plus 324 equals 576. So x squared is equal to 576 minus 324 is 252. Then take the square root of both sides. You get that x is equal to 6 square roots of 7. So yt is equal to 6 square roots of 7. And we like to leave in stuff in square roots now from now on. All right, and that's C1. That's our basics of circles right there. Every video from there after this will follow from these definitions and stuff. So please email me if you have any questions. And thanks for watching the video, guys.